All right, so this is parallel now. So now we are going to leave behind what we learned about series circuits, and we are going to start looking at parallel circuits, okay? And I'm going to warn you in advance, you do not know what is going to happen. So please make sure that you actually look at the evidence that is created and don't pre-assume that you know what's going to happen, okay? Or else then you're probably going to be in a bad spot. All right, so for the first part, we're going to talk about the current in a parallel circuit. So again, we want to look and see how does the current compare through each resistor, and how does adding more resistors in parallel affect the overall current, right? So let's go ahead back to the simulator again. All right, and the first thing that we need to do is we need to hook up a circuit that is in parallel, okay? Make sure that you set the first part like this, okay? Make sure that you set ammeters, okay, here and here right next to the battery, okay? That's going to be super important in this one. So make sure you set it up like this, okay? And then I'm going to go ahead and put a resistor like this, okay? And then I'm going to put an ammeter like this, all right? And I'm going to go ahead and change my battery voltage to 10 just because it's a little cleaner. Okay. All right. Good. All right. So here's what I've got. So this is actually just a series circuit because there's only one resistor, right? If there's just one resistor, it's not hooked in series or parallel. It's just what it is. Okay. But this would be more like a series circuit because it just has one resistor in this path. Okay. All right. So now we have this. Okay. So this is our first kind of like generic setup. Now what we want to do is we want to hook one in another resistor into parallel, okay, which means we want to make another whole branch, okay? So what I'm going to do is I'm going to create one that looks exactly like the first one, like a duplicate. All right, so you see each one of these now in this path, there's a resistor and an ammeter. In this path, there's a resistor and an ammeter. Okay, so this is what you're looking for, all right? So now the two questions that you're going to have to answer, how does the current through this resistor compare to the current through this resistor, okay? And then the second question is what happens to the overall current as I start to add resistors, okay? So the overall current means these ammeters here, the ones that are closest to the battery. Okay, because what's going to happen is as this charge starts to move around, there's going to be this junction right here. Okay, and the charge is going to split. Some is going to go this way, some is going to go this way. Okay, so you want to think about what's happening there. Okay, whoops. All right, you can continue to add more. All right, exactly like it did in the first place. Okay, so see again, now I've added a third branch. Okay, so again, you want to compare what's happening in each branch. Okay, and then what has happened to the overall current? That's what I'm measuring right here. Okay, so again, for your evidence, you're going to need some kind of screenshots, some kind of drawing, some kind of data table. You could try to graph it. It might be a little tight, but you could try. Okay, and you want to answer those two questions, all right? So I'm looking at the individual branch or resistor currents here, all right? And then I'm looking at the overall current here, okay? And you can add up to another branch if you want, okay? Then what you will do in your slide, okay, is here, you're going to put your evidence, all right? So you may, again, you may have some kind of a data table, like number of resistors, maybe like overall current in each, something like this. I don't know, however you want to arrange it, it's fine. Okay, it would probably be a really nice idea to have little screenshots or little drawings, right? What happens if there's one branch, two branches, three branches, right? Okay, and then you're trying to describe what happens to that current, okay? Both current in the branch, right, through a singular resistor, and then the overall current in the circuit, okay? That's the one next to the battery. That would be the overall current, okay?